Welcome back, and in this short series we will discuss 3 methods to calculate the maximum effect of the tree's ytmax from this tree suction induced profile. In previous videos we have shown one method to calculate the average suction change of every layer, delta U1 and delta U2, the length of the red line here, and that was to simply draw it to scale on a CAD program and then measure it straight off. But in this coming presentations we will discuss 3 techniques we can utilize to manually calculate ytmax. The first method is called the simple trigonometry method. We will be utilizing a lot of similarities of triangles. Now, before we proceed to method 1, I would like to refresh our memory on the equation of evaluating the ytmax as shown here. And if you remember the IPS value, which is the soil shrinkage index, then we multiply that by the alpha factor, and that these two will be the instability index. And then we multiply that by the average suction change of the layer as well as the corresponding layer depths H to get ytmax. Now the sum of the product of the average suction change and the layer depths throughout the whole profile is simply that value of that hatched area. Okay, and remember that the alpha factor is 1 as the whole profile is cracked due to the effect of the trees. Now got that out of the way. Now let's get straight into method 1. Okay, what is involved? Well, we first take this slice on its own, then draw a straight line from the top of that triangle, that yellow line here, and we draw it right to the base to make a 90 degrees with this little distance which we will call x1. Then at the point where the profile changes from this vertical line to an angle, we will call this horizontal distance x3, and then add another line x2 to be perpendicular to that yellow line we drew before. Now before we get to x4, let us work out x1, x2 and x3. Okay, x1 is simply 0.6 minus 0.55, and that will be 0.05. Now where does 0.6 come from? It is half the suction change at the surface. The suction change at the surface is 1.2 picofarad, half of that is 0.6. Okay, so x1 is 0.05. Then from similarities of triangles, we can then say x2 divided by x1, which is 0.05, is equal to 4 divided by 4.5, and x2 would be 0.044 picofarad. Yeah, so far so good. Then we can say x3 is simply 0.6 minus 0.044, and that will be 0.556 picofarad. Yeah, and so what is left? Delta U2 is the average suction change of that second layer, which is simply 0.55 plus 0.556, divide that by 2, and that will give us 0.553 picofarad. Now that was, I think that was a piece of cake. That was easy, and I think it's all fun and games. So now let's go to x4. Okay, so we called this little yellow line x4, which is parallel to delta U1. So then we can say from similarities of triangles, x4 divided by 0.044 is equal to 2 divided by 4, and therefore x4 is 0.022 picofarad. Now remember x2 was 0.044. Okay, so that would be like x4 divided by x2 is equal to 2 divided by 4. But we can also say, to get delta u1, we can add delta u1 to x4. So we can say delta u1 plus x4 is equal to x2 plus, my apologies, so delta u1 plus x4 divided by x2 plus x3 is equal to 2 divided by 4. And that again is from similarities of triangles. So then we can solve for delta u1 and we will get 0.278 picofarad. And that's all it is. We then take all of these values along with the soil shrinkage index and work out ytmax, and we will get a value of 40.5 millimeters, which is exactly the same answer as the example that was given to us in the code. So in the next video we will discuss method 2, which is the area method, and it's so much easier and more simpler than this method. I would love to answer any questions you may have, and of course your valuable opinion on this topic. So please feel free to drop us a comment below. We hope you've enjoyed this little video, so please subscribe, share and like so that others may also learn. Until next time, we hope you have a great afternoon.